Okay, separably differential equations, sometimes just called diff-EQs. There's a whole college class that's just, it's called differential equations. It's just on this, so you could like just really get your sink into it. This works best with Leibniz because integrals always favor Leibniz notation. A differential equation is set up as a dy dx with Leibniz, and so it's just your directions are to solve that differential equation. And so in Leibniz's form, you're asked to solve dy dx being equal to the secant squared of x plus 2x plus 5. Okay, this is called a separably differential equation. The differentials are the dy and the dx. Those are two separate differentials, that's what we call them, and so we separate them onto both sides. And so it looks like this. So dy is separated from dx, and dx is moved to the other side. So we separate, followed by integrate. So separate and integrate. So once you've done the separation, then we integrate the dy side, and we integrate the parentheses side. Dx. And then we just integrate each piece as we go. On the left side, the integration of dy is regular y plus what we would call constant 1, because every integral produces an extra constant. On the right side, each piece has its own integration. Does anybody want to try each piece? Okay, tangent x, then what? And then x squared, then what? 5x, and then a second constant, which we combine the two constants together, and so the solution of this is y equals tan x plus x squared plus 5x, just plus a universal c that covers both of them combined together. So pretty simple, separate and integrate, pretty straightforward.
So wait, how did you get, so C, regular C is basically the equation C2 minus C1?
Yes, because when you subtract one constant minus another, it's just a constant.
Yeah, but
and
what if it's like a specific constant, like what if it's like a point, like then you need...
That's our next question. All right. So yes, you're anticipating exactly what I'm thinking. All right, so the second differential equation we're going to do is to solve dy dx equals e to the x minus 6x squared through the point 1, 0. And so having that additional point is going to help us narrow down what the value of plus c needs to be. So we separate the e to the x minus 6x squared times dx. So we perform separation first. And then once we've done the separation, we can put the integration on there. And we'll have y plus a constant. And the antiderivative e to the x is just e to the x again. Minus 2x cubed plus a second constant. So overall, e to the x minus 2x cubed plus an overall constant. And then we know that this has to go through the point 1, 0. So 1 is the value for x, and 0 is the value for y. So e to the first minus 2 times 1 cubed plus c. So c ends up to be positive 2 minus e, which is a constant. because 2 is a constant and e is a constant, and so the subtraction of those two is a constant. And so our overall solution would be e to the x minus 2x cubed plus 2 minus e. And that's the solution to the differential equation.